Hello everyone, welcome to the last part on the series of microservices. In this video, we are going to implement the choreography Saga pattern. We have already implemented the orchestration in our last video, so let's get started. You already know for the choreography Saga pattern it's being used for the asynchronous communication. So therefore, we can use the event-driven approach. We can use the pub/sub model, or we can use the message brokers. In this video, we are going to use the RabbitMQ to send the messages or receive the messages on the other end. The structure is same. We have the API gateway, inventory API, order API, and the product API. So what we are going to do now, I'm going to add a new project. We'll call it a notification. So what would happen when the order is placed? We would send the message to the notification to proceed with the notification. We don't wait for the notification to reply us back because that's the asynchronous communication. We won't wait. Once the order is done, we will show to the user the order is placed, and we would send the notification to the notification project, and it's up to the notification how the notification is going to be handled. So this is how we are going to implement it. So first we have to install the RabbitMQ. Okay, so we can go to the RabbitMQ official website. You can go to the documents and the downloads. You can see here we have to install the RabbitMQ. If we want to install in the Docker, we can use this command. Okay, it's similar to the console. It should be running, right? So the best is to use the Docker. The service would be up and running. So I'm gonna copy this one. I'll copy this one. If we copy from this button, it will copy the latest as well. I don't want that. I have the terminal opened here. I'll paste it here. I'm going to execute it. So you see here it's downloading the image. Once all the dependencies are downloaded, it will automatically start the service. We can see it here. Okay, we can see it here. The RabbitMQ, the image is being downloaded and it's in use. We go to the containers. You can see here it's running. These are the ports where we can access it. If we click on it, you see I did the login today itself, so that's why it didn't ask for the login. If I log out here, this is the default page that you will get. By default, guest is the username and password, so you will log in by using the guest. We have no connections, no channels, exchange queue, nothing. Okay, so now the RabbitMQ is installed. Let's add a new project. We'll call it a notification. I'm using an empty project. Okay, this one. Okay, notification, create. Okay, so the project is added. Let's add the RabbitMQ NuGet package. We'll go to the notification and manage NuGet package, search RabbitMQ. RabbitMQ.client that needs to be installed. We'll add the package here. We'll have to install the same package in the order API as well. So let's do that as well. RabbitMQ .client and package. Okay, so now we'll implement the listener first. Okay, so we can create a class. Let's call it a message listener. Okay, so this message listener, it should always be in the running mode. So for that we can use the iHosted service. Okay, and we have two methods, start async and the stop async. Okay, so we need two variables. They're called I connection, I guess. It's part of RabbitMQ. Yeah, so we call it connection, and we have the another variable that is I model. We call it a model. Okay, so now we have to create the instance of connection factory we have inside the RabbitMQ. Okay, here we have to provide the host name. The host name is the local host. Maybe this information can be added in the configuration. Username is guest as we discussed. The password would be guest as well. Okay, this is the basic configuration. Okay, so the connection is equal to factory dot create connection. It will create the connection for us, and with the help of this instance connection we can create the channel or model. You can call it a model. So model is equal to connection dot create model. Okay, so once we have done this one, we have to declare the exchange. We'll understand what's the exchange is. So we can declare the I model dot exchange declare. Yeah, so we have the exchange name. Let's call it order exchange. The type would be topic, and the other durable is false, auto delete is false, and the arguments is null. Okay, then we have to declare the queue as well. Okay, because the message we are going to get, they are going to be queued based on the routing. Okay, we will also talk about that as well. The call order creation queue maybe. Okay, so again durable false, exclusive false, auto delete is false, and the arguments are null. Once we declare the queue, we can bind the queue. Okay, model dot bind queue. Okay, here we have to provide the queue name, that is order creation queue, and we have to provide the exchange as well. You'll understand it. Let me just complete this one. I'll talk about it. And the routing key order dot created, and the arguments are null. Now let's understand it. So this connection factory, it needs this username, password, and host. So it would know that the RabbitMQ is running on localhost, and these are the credentials. Okay. With the help of connection factory, we create a connection. So we make a connection with RabbitMQ, and we check, okay, RabbitMQ is running, and we it will return the instance of the I connection. So this connection, with the help of this connection, then now we have to make the exchange. We have to declare the exchange queues, and we have to create the channel as well. This create model is going to create the channel. We have made the connection. Now the channel is required for the message exchange. It could be a TCP. Okay, so once we get the channel, now we have to declare the exchange and the queue. So what our exchange is, let's say our RabbitMQ is running on localhost, and there could be we could be using the RabbitMQ for different APIs. There could be 10-20 different APIs that are using the RabbitMQ. So how would we know that this queue should belong to the order exchange, this is for the product exchange? So it's like for the better management, we should have the different exchange declare, and these exchanges are, we can bind the queues to these exchanges. Not every message that we get we should push into one queue. It's going to be messy, it's difficult to be handled later, and whenever any error occurred, it would be difficult to figure out where it happened. So better to declare queues. So that's where I have declared the queues, order creation queue, and the name should be very specific. So by reading the name we can see, okay, this is the queue that we declare when we create the order. So again we have to bind this queue to the exchange. Okay, that's what we have done. This is the routing key. The routing key is actually for this order creation queue there could be different messages. These are the type of messages. Order dot created message, who would listen? This message listener would listen. And maybe we have the other API or the other project that is called payment notification, right? So payment gateway could be there. So once so for that we can declare a new routing, maybe order dot proceed payment. Okay, and then that project payment gateway would listen to this proceed payment. Okay, so this is actually a type of message, and based on that the message would be received by the message listener based on the routing key. I hope it's clear. If it's not, I will definitely understand when we go through, when we send the message, and we'll see how it reflects on UI and how we are getting the message. Okay, so we have declared it. Now let's create the event listener. Okay, so how can we do that? We have to create the consumer here. Consumer is equal to new eventing basic consumer, I think. Yeah, if you see here we have to pass the model. The model is the model we have here. Okay, so this consumer would listen to the events that we have declared here. So this is going to handle the events. Whenever we get the event it would listen to it, and whatever we want we can implement the logic here. There could be a couple of queue binds as well. So let's me add this one. Okay, so now this notification is responsible whenever you get the order dot created or maybe order dot failed. Okay, let's start with 2. Okay, so now when the order is created, the message, the email that we are going to send to the user is going to be different, and for the failed it's going to be different. So what we can do here in the received event listener, we get the body, we get the message that we have published, right? If you see here in the body, it's a read-only memory bytes. Okay, so we have to convert this to array so that we can convert into the JSON or the string format for better understanding what the object type is, where what is the message is all about. Our message is equal to body, not body, system dot text dot encoding dot utf8 dot get string. Okay, and we can pass the body here. If you see here in the get string, it takes bytes array. Okay, so that's why we convert this to an array for get the readable message. Now if you see here, we can also get the routing key. This is called the routing key. This order dot failed and order dot created, or the routing key. Now what you can do here, you can check if the routing key is equal to order dot created. Okay, like this. Maybe you send the success message. Okay, send success mail, else it would be unsuccess, right? So we can do this one, we can check it here. Okay, but for the time being I'm not going to do that. I'm just going to print the message that we have received. So console dot write line message is received, then we can write the message here. If you want, you can add the routing key as well. Okay, now we would bind this to the channel on the model dot basic consume. Okay, here you see we have to pass the queue name again. It's better to declare all these in the variable so you don't have to copy paste each time. This is the queue we have. This is the auto acknowledge. You can auto acknowledge it. So once you receive the message, we have to acknowledge so that it would be deleted from the RabbitMQ and the consumer that we have just created. That's all. That's all what we have to do. And this is the task. We also have to declare the async. Okay, and we can declare the async here as well. So when we close this one, the service, we have to close the connection and the channel, right? Connection dot close and the model dot close. That's it for the message listener. We'll go to the programmer CS builder dot services. We add the as singleton. Okay, we pass the I hosted service and message listener is the implementation. Let's see the RabbitMQ UI first. So in the connections we have nothing, channel, exchange, queues. We have no declaration or no bindings mentioned here. Let's run this one and we'll see. Okay, it started. Now if you come here, you see the queue and the exchange is there. The order dot exchange is there. Okay, and the queue is also there, order dot creation queue. Okay, so that's why we need the listener to start first, so it will create the queue and the exchange. Now how does it work in the RabbitMQ when we send the message? Let's say from the order we are sending a message, order is completed, and we are sending the routing as order dot created. That's what we mentioned in the listener. So what happens, we send the message to the exchange. We don't use the queue there in the while we are sending the message. Okay, so it comes to the exchange. The exchange order exchange would get the message order dot created, and the RabbitMQ would run the algorithm. It would find in which queue the order dot create or order dot created routing key is mentioned, and it finds out that that order dot created routing key is mentioned in the order creation queue. So the message that we have sent from the order API, it will be pushed into the order creation queue. That's where our listener is listening to this queue. Once the new message is being pushed into this queue, our listener would listen to it and would act on accordingly. Okay, so this is how it's implemented. I started this service because we are going to start the order service, order API. Let's implement in the order API right now. Okay, so in the order API we have already installed the package. I'll not be going through all these steps. Instead, what we can do, I'll comment this code. Okay, and here we would send the message. Okay, in the same way we can also create a class here. We'll call it a message broker. Okay, I'll copy the code from the message listener. This is pretty much same. Okay, this message broker would come here. We won't declare the queue. Okay, we just declared the exchange. Okay, that's it. Now we create the method public static, not static, public void send message, and we give the string message here. Okay, first we have to convert this message, right? We serialize the message by using the JSON serializer. So JSON is equal to JSON serializer. dot serialize the message. Okay, now we have to encode this message. We use same system dot text dot encoding dot a dot get bytes. Okay, and the JSON. Now we can publish this message. How we can do that? We can use the same model dot basic publish, and you can see here we can mention the public address properties, or if you go to the overload, the next one is the exchange. The exchange would be same. This queue should be deleted. The exchange would be same, and then we have the routing key. The routing key would also be same order dot created. So the next one is we have to provide the basic properties. So how can we do that? Basic properties, it's a couple of settings that we want to declare what the content type would be, the media type, the headers. So we can declare it there. Create basic properties, basic dot see the content encoding, content type, headers. So we can declare that. I'm just going to use the content type to mention as JSON. Basic properties, and the body is the message that we have. That's it. Okay, so we can use this message broker in the order controller. The message broker is equal to new message broker dot send a message hi from order API. This is it. Let's run this order API, see if it worked. Run project. Okay, it's up. It's part of the creation. Okay, you see here we have no messages, nothing is there in the exchange, in the queue, no messages there. When we push this one, we try it, we execute it, and if we come here, it refreshes after 5 seconds. Okay, you will see it is saying that there is some messages being sent. Okay, we can also check the message in the RabbitMQ as well, but it will be deleted. Okay, but again our listener is listening to it, so the message is automatically deleted because we have mentioned the acknowledge. Now how can we check if we have received the message? We'll go to the notification output. Okay, see the message is received hi from order API, the routing key is order dot created. So this is how you can implement the RabbitMQ or the message broker or the asynchronous communication in the microservices. So that's it. I hope you have understood how we can implement the asynchronous communication by using the RabbitMQ. This is the way that we can also implement the choreography Saga pattern. Of course, it would be involved to add the transactional statements, but this is just a basic understanding how we can implement the PubSub model. So that's all from my side. Thank you for watching. If you enjoyed this microservice series, please subscribe to my channel for more great content. And if you have any question, query, or topic or suggestion that you want me to create the videos on, please add in the comments. So I guess that's all from my side. Bye bye.